So Kathleen already talked a bit about my background, but I want to start to tell you a bit of why we being my co-founder Felix Hupferl and me, started Quobyte. Both of us did our PhDs at a research institute in Berlin, Germany, that is also a high-performance computing center. And this is where we started the project XtreemFS to find out how you can combine distributed systems, fault tolerance across machines and data centers with a POSIX file system that applications can simply use without being modified. After finishing our PhDs, both Felix and I joined Google. He joined Google a bit earlier. And at Google, we learned we saw how infrastructures at a very large scale are built in software and how you make sure that you can operate them with tiny teams. And I think that's the major difference if you look, for example, at the story of internet companies like, let's say, Yahoo that went with traditional infrastructure and Google that built everything on scale out in software. You can see the dramatic difference there. So at Google, we learned how you need to build systems so they can be operated at scale with small teams. And that's the reason that we started Quobyte in 2013. We wanted to bring those two worlds together. On the one hand, the scale-out workloads, because we believed that what was called high-performance computing would arrive in the enterprise. And then on the other hand, if you have a lot of data, you need the scalable operations that we saw at Google. So that's the reason that we started Quobyte. And part of the idea that we have when starting Quobyte was that we looked at the storage industry. And if you look at what storage looked like 20 years ago, around when the new millennium started, there were VM infrastructures. So virtualization was a hot topic, just taking off. There were bare metal servers. It was built a lot around databases, transactional workloads. The amount of data that most companies stored was rather small. And enterprise storage was usually appliances, single appliances that offered decentralized storage for that. Then, and you at Samsung know that best, the storage industry had a massive change or a massive revolution with the arrival of flash and affordable flash. So suddenly, the appliances could change and enterprise storage could deliver much more IOPS than ever before. There started a all-flash appliance craze with the idea that applications needed 1 billion IOPS. So for those of you who know Austin Powers, that's why I have Dr. Evil here, because the 1 billion IOPS sounded good, but in the end, there were only a few consumers that really needed, or a few enterprises that really needed the high number of IOPS for their databases. Most of them had medium to high IOPS requirements, but definitely not that crazy. But the storage industry somehow saw flash and decided that everyone needs billions of IOPS. You know, new technology leads to people trying out what you can do with that. But in the meantime, while enterprise storage was focusing on adopting flash, other things happened. Part of it is that the hardware changed. So flash became a commodity. With NVMe today, flash is everywhere, and most people have it in their phones, in their computers. Then networks became significantly faster. 20 years ago, a gigabit was fast. Today, we have 100 gig Ethernet. It's, compared to other components in data center, it's very cheap. So it has become a commodity and the standard. And then at the same time, x86 CPUs became so fast that they are now the de facto standard, and other architectures have more or less subsided. All of that enabled new paradigms in computing. And the applications changed too. And a driving force here was Google, because they demonstrated what you can do with scale out. Urs Hölzle of Google coined the term warehouse scale computing. So basically having a large data center full of computers, and instead of trying to build supercomputers from custom hardware, let the software be distributed across the machines and turn into one big system. And Google pioneered this and made a lot of the ideas available through publication. So they wrote the MapReduce paper, which then inspired the Hadoop project, which is now a standard. Wherever you look, most companies have Hadoop somewhere in their architecture, somewhere in their systems. But Google also provided other ideas like Kubernetes. Kubernetes is built after Google's own cluster manager, Borg, is hugely successful, and basically all cloud providers now provide Kubernetes engines, and it's used by a lot of teams around the world and companies to run a variety of workloads, from internal developer workloads to production workloads. And then the latest craze, machine learning. Google provided TensorFlow, others like Facebook implemented PyTorch, and all of those workloads have moved into the enterprise and have established scale out in the end high performance computing as a major requirement in enterprise IT today. And then the third thing that happened is that, again, demonstrated or initiated by the hyperscalers, people saw that collecting a lot of data and getting insight from that became a major competitive advantage. So in 2014, The Economist declared data to be the new oil. So a lot of companies realized that they can gather a lot of information, whether it's sensor data from the factories, it's telemetric data from the cars or machines that are out there in the factories and on the streets, or a bit more controversial, user data. All of this is super valuable, but you have to be able to store it and then take advantage of it by analyzing it, which is where the scale-out workloads come in again. So what happened with enterprise storage in the meantime in the last 20 years? Well, it kind of looks the same, and that is one major problem. So on the left-hand side, you can see the workloads that are now scale out. So they changed away from the monolithic databases where they thought they needed millions of IOPS or billions of IOPS to thousands of compute nodes accessing the storage in parallel. And then on the other hand, we have this enterprise storage now with Flash, but still not scalable. So you have a massive mismatch of architectures. The enterprise storage is almost still the same as it was 20 years ago. And you can imagine, with the faster networks from the client machines and the demanding workloads like machine learning, we now have a massive bottleneck in I/O. And it's not a surprise that when you talk to analysts in IT, that over 60% of the people they ask admit that central IT is a hindrance to innovation. And storage is a big part of that. The traditional enterprise storage simply was not designed for those kind of applications. So the scale-out use cases that I mentioned are machine learning, which is a hot topic, Hadoop, Spark, so the whole analytics set. Then, of course, the traditional scientific computing, high-performance computing. Some of that is more prevalent in the enterprise if you think about financial simulations like risk analysis, back testing for trading strategies, or fraud detection. Those are actually HPC workloads. But also the more traditional engineering workloads like EDA or chip design are massive scale-out workloads because the computational side is spread out across thousands of compute nodes. And then you have the newer workloads like Kubernetes clusters that I mentioned, where the engineers and the developers have already moved to the scale-out world. I think that's a particular challenge, and that's what we call the generation scale-out. Application developers, data scientists, and the people that run the Kubernetes clusters have fully embraced this new way of doing things in scale out. And for them, working with central IT and monolithic storage appliances is a major mismatch, and it's leading to frustrations. So they need new solutions, and IT departments should actually help them solve their problems, because otherwise what will happen is that people will move into the cloud simply because they cannot get the performance or the storage and the infrastructure they require from central IT. So this is where Quobyte comes in. If you have workloads like the ones listed here, you'll benefit from using Quobyte, either as a user or as someone who runs IT infrastructure, to deliver the performance and the scalability that the applications and the users need. So in a nutshell, Quobyte is a software storage system. So we moved away from the very hardware-centric approach that storage always had to something that we learned at Google, a fully hardware-agnostic model where we do everything in software and basically have the assumption that we don't trust the hardware layer because hardware will break eventually, and it's easier to do that in software. As I mentioned, we built our product on the experience we had at Google on how to build infrastructure that scales on the operational side so that a small team can run very large clusters. And on the other hand, how you best serve applications that have this HPC scale out need, even if they are in the enterprise. We have been in production for over 4 years. Today, we have, for example, STFC in the UK as one of our customers. They just added, or were just added to the IO500 list as number 6 in the world. So they have the 6th largest cluster on that supercomputing list. And this cluster is powered by Quobyte. It's used for 3 years now in daily operations of their supercomputer for applications ranging from weather simulations to machine learning applications. But we also have commercial customers like Yahoo Japan that runs a Kubernetes and OpenStack infrastructure on us. This is an all-flash installation focused more on transactional workloads, high IOPS, but also machine learning. And we have a global financial company that runs a 185-node Quobyte cluster. Again, has been in production for 3 years, mission critical, up 24/7. So we can serve a variety of scale-out workloads from traditional research to very demanding enterprises like financial companies. And the reason that they decided to go with Quobyte is because they like the way we approach storage, because it's radically different. So it starts with unlimited performance. The real benefit of good scale-out architectures is that you can always add more hardware to scale your performance. So in Quobyte, it's linear scaling. You can start with 4 machines. If you go to 8, you'll get twice the performance in terms of IOPS, bandwidth, and capacity. And our architecture is designed in a way that there are no bottlenecks. So you can scale linearly to thousands of servers and match even the most demanding I/O requirements like you have with the 6th largest storage infrastructure for supercomputing on this IO500 list. And then another point where we're massively different from other vendors is that we have this deploy anywhere strategy. We let you use almost any x86 server with hard drives and or flash in them. You can also run us on the cloud and in containers. So no matter how your business requirements change, you might start on the cloud with an experiment, and then as it grows or you start processing mission critical data, you can move back on-prem with the same system. And all of this is very simple. We made sure that small teams can run very large clusters. So that's basically the Google-style operations, because that's the only way you can run large infrastructures, because no one can find more people if they need to add storage. So in terms of performance, we now have a good match between the scale-out workloads and a scale-out storage system. On the other hand, you can see that here, all servers or all consumers directly communicate with all Quobyte servers. You have a full mesh architecture where you can basically run as fast as your network or your storage media. You can always add nodes, and there are no bottlenecks here. It's direct communication, and we can deliver line speed up to 100 gigabits per second to a single client and also from a single server. So in the end, if you need more performance, you can just plug in more servers and do that at any time. Then on the deploy anywhere, you can see that here we have an HPE and a Dell server. Our customers run on a wide variety, including Supermicro and almost any vendor out there. They can also run multiple vendors in the same installation. And as I mentioned, depending on the workload, they can put in flash drives for the high performance workloads, for small file workloads, and then use cost-effective hard drives for the archiving part. So it's also not a surprise that Samsung invested in our company in 2016 simply because we can turn any server with NVMe or flash drives into a high-performance storage system. Then on the public clouds, you can use this out of the box. We are on the cloud marketplaces on Google and Oracle, and you'll find us soon on AWS and Azure. You can move data between the clouds and also do a hybrid approach where you have an installation on-prem plus clusters in the cloud and then move data between them. A typical example is peak workloads that need to move in the cloud because you are on a tight deadline. So this is very simple to implement with Quobyte. And then in containers, that's particularly interesting. You can run Quobyte in containers, and then storage becomes simply another application that you run on your cluster. So we're going away from something that requires special hardware, super specialized knowledge, to something that you run like any other Linux or containerized application. And that really ties into our promise of unconditional simplicity. So installing Quobyte, you can get it from our website. It doesn't take more than a few minutes. We made sure that the whole software is in user space. You don't have to fiddle around with kernel modules, compile stuff, or anything like that. Our goal is that anyone who knows Linux can do storage. And as I mentioned, running Quobyte as a container application, as yet another application in your container infrastructure, is part of delivering this on this promise. But there's more to it. With Quobyte, you can run 24/7 without maintenance windows. That's part of the hyperscaler style operations. Everything can be done while the system is online, which means that the teams now can operate on their own schedule. They don't need to do maintenance windows at weird times of the day. They don't need to run when something breaks. So it's more, they're able to handle more servers. And if you look at Google, they published those numbers in the book I mentioned earlier from Urs Hölzle. A single admin in a Google-style data center can operate or maintain between 10 to 100 times the servers of a traditional IT admin. So the time savings the teams have are gigantic, and that's the key to enable them to run very large infrastructures. And in Quobyte, that's the key to making sure that a team of 2 people can manage a 100 petabyte plus cluster, even if they're responsible for the hardware. Then something we added in our latest release that came out 2 weeks ago is security, because that is a major topic in most enterprises. Whenever we talk to prospects and our customers, this came up in every discussion with things like GDPR, where companies get hefty fines for data breaches in Europe, and now the same probably happening in California. Storage systems and encryption have moved into the focus. So we decided to implement end-to-end encryption so that data that leaves the client machine is always encrypted. The great advantage here is that with the Quobyte system, you don't have to trust the network, you don't have to trust the storage system, the people that run the storage, or the people that maintain the servers or the physical hardware. So with this enhanced level of security that you don't find in storage systems that rely on data protocols like NFS, you can fulfill higher standards of data protection than before, and you have the support from the storage system. With that, so we call it 360 security because we don't stop there. We have TLS encryption between data centers. That allows you to have secure communication for multi-cluster setups, which are important for a variety of applications. I mentioned the cloud, or using hybrid on-prem and cloud, but also if you think about edge use cases where you have maybe smaller Kubernetes clusters with a Quobyte installation in a large number of data centers, and they all feed the data into main data centers. Using TLS allows you to make that communication secure and high performant without requiring additional hardware like VPN gateways. And then finally, we have X509 certificates and access keys to make sure that you can restrict the access to the system and only authorized users can access data, talk to the system. So you have a holistic approach to securing the data, making sure that access control is properly enforced. And then the last important feature of our system is what we call grand unified storage. So we allow you to access the file system and the same namespace from all protocols, meaning that you can access it from Linux via our native Windows drivers. You can use our native Hadoop drivers to run your Hadoop workload on the same data, but also access the files via S3 so that you can share data, for example, over the internet in a secure way. And instead of having silos in your enterprise for different applications, you can now share data to a wide variety of users and applications, and that way make it much easier to implement, for example, data lakes where everyone can access large amounts of data for analyzing it, and doing so in a safe way, in a secure way, with the encryption and the access control that I mentioned. Unified ACLs are part of this. So managing access rights is very simple with Quobyte because there's only one set that is enforced across all the protocols. So that makes it very easy to ensure that only the right people have access to your data and also audit access rights, whether it's people access from Windows, Linux, or S3. So that's a big advantage, tying back into the security aspect. And that's another thing that we added this month, our free edition. So if you think this sounds too good to be true, or this is too much marketing and you actually want to see this, you can download our free edition from our website or use our containerized version. You see this one-click install here that you can use. You get up to 30 terabytes of SSD storage for free and can also use it in production. So if you have a small project and want to get started with storage, you can just download Quobyte, run it on VMs, run it on your servers. And if you need support, we do have a community forum, but we also do regular office hours with our engineers. At the moment, they're virtual. And if you want to test the whole functionality, you can also contact us to get POC licenses to try all our features. But I encourage you to try our free edition to see for yourself the advantage of running a Quobyte cluster.